purpose of this tutorial is to give a basic introduction to some of the functions of trigonometry, and in particular the sine, the cosine, and the tangent function. In order to understand trig functions, one of the very first things you have to do is understand that we're using a right triangle. And all of these right triangles have a hypotenuse. Remember that the hypotenuse is always the angle that is opposite the right angle. Every single triangle that we're going to use will have a hypotenuse if we're doing the trig functions. The hypotenuse is directly across from the right angle. The other two sides that we have to worry about when we're doing trig functions are the opposite and the adjacent. And the opposite and the adjacent depend upon which angle we're asking. In this particular case, I've got a right triangle, and I have an angle A down here in the lower right-hand corner. Well, which side is opposite A? Directly across from A, we have an opposite side. The side that is not the opposite and is not the hypotenuse is called the adjacent. So with respect to angle A, this is where my opposite, adjacent, and hypotenuse lie. What if instead I was looking at this angle, angle B? Well, the hypotenuse is always opposite the right angle, so the hypotenuse is going to stay the same. However, now if I look across from angle B, what was my adjacent for angle A is my opposite for angle B. And what used to be the opposite for angle A is the adjacent for angle B. So, oops, that didn't work very well, did it? So clearly it depends on which angle we're talking about. The hypotenuse is always going to be the same. I find it easier for students if you get the hypotenuse first by going straight across from the right angle. Look at the angle you're talking about and make sure that the second angle that you look for is the opposite. Now, the three trig functions that we're going to talk about today are the sine, the cosine, and the tangent, and all they are is definitions. The sine is just defined to be the opposite over the hypotenuse. The cosine is defined to be the adjacent over the hypotenuse, and the tangent is defined to be the opposite over the adjacent. These are very, very important functions, and so we expect you to memorize that. We have a couple mnemonics that we have used in order to help people understand or remember which function is which, the sine, the cosine, and the tangent. One of the most familiar that we have is SOHCAHTOA. Notice that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. SOHCAHTOA, an old Indian word meaning trigonometry. That one is fine. That's not the one that I was told when I was growing up. The one that I always remember is a phrase, some old hippie came around here tripping on acid. Why I remember that, I'm not sure, but it worked very well for me. The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. Some old hippie came around here tripping on acid. I've also heard some old horse caught another horse taking oats away, and a bunch of other little things that we have. These are the two main ones that I remember. SOHCAHTOA you'll see just about everywhere. I don't care how you memorize it. I just want you to know that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Commit that to memory, please. Okay, so I'm going to give you an example here. I want to know what is the sine, the cosine, and the tangent of angle A. Well, the first thing that we have to know is with respect to angle A, what is this hypotenuse, what is the opposite, what is the adjacent? Well, we know that the hypotenuse is always opposite the right angle, so 10 must be the hypotenuse. Remember, I'm talking about angle A, so 6, whichever side has length 6, that has to be the opposite, and the other one has to be the adjacent. I want to know what is the sine of A. Okay, well, the sine of A is equal to the opposite over the hypotenuse, some old hippie, Since the sine is the opposite of the hypotenuse, in this particular case, the sine is 6 over 10, which can be written as 3/5. The sine of A is 3/5. The cosine of A is the adjacent over the hypotenuse. In this particular case, it's going to be 8 over 10, which is 4/5. And the tangent is the opposite over the adjacent, tripping on acid. Opposite over the adjacent is 6 over 8, which is 3/4. All we did in these particular cases is we made sure we knew which was the opposite side, which was the adjacent side, which was the hypotenuse, used our definitions for sine, cosine, and tangent, and that will give us the answers. We'll do an awful lot more of these in future tutorials, but if you can do this for me here, everything is going to be fine for getting a really good foundation for using trig functions. Example 2. It does not want to go away. All right. So we'll just leave it there. Give the sine, cosine, and tangent of a 30-degree angle. This is going to work for any 30-degree angle. I know a few things about a 30, 60, 90 triangle, because remember the 30-degree angle is here. Trig functions only work with a 90-degree angle, meaning the third angle has to be 60 degrees. I don't know what the length of the side opposite the 30-degree angle is, but I'm going to call it x. Because it's a 30, 60, 90 triangle, I know the hypotenuse has to be twice as big as the shortest leg. And I know that the side opposite the 60-degree angle, the longer leg, has to be the shorter leg times the square root of 3. Compared to the 30-degree angle, x is the opposite. X root 3 is the adjacent. And 2x is the hypotenuse. So what is the sine? The sine is the opposite over the hypotenuse, some old hippie. In this particular case, it's x over 2x, which is 1/2. The sine of a 30-degree angle is 1/2. In fact, we'll get a calculator a little later on, and we'll show every time you do the sine of 30 degrees, you'll get 1/2. What is the cosine of 30 degrees? Okay. In this case, the cosine is the adjacent x root 3 over the hypotenuse 2x. The x's cancel out. The cosine of 30 degrees is always going to be the square root of 3 over 2. And finally, what is the tangent? The tangent is the opposite over the adjacent. It's going to be x over x root 3. The x's cancel out, and I get 1 over root 3. Simplifying 1 over root 3, and I'll do this for you. 1 over root 3, I'm going to multiply the top and the bottom by the square root of 3. I'll get the square root of 3 over 3. The tangent of 30 degrees is equal to the square root of 3 over 3. Just using the basic properties of trig functions, knowing which sides are my opposite, adjacent, hypotenuse, I can tell you what the sine, the cosine, and tangent of 30 degrees will be. All right, problem 1. I want you to try this one here in a minute. What I'm going to do is I'm going to tell you that we're looking at angle B. Tell me, according to this triangle, which one is the opposite, which one's the adjacent, which one is the hypotenuse. Let's pause our video and try it now. Okay, across from opposite C, because C is the right angle, the one across from it is going to be the hypotenuse. The one, remember we're talking about angle B, the side opposite is going to be the opposite, and the other side is going to be the adjacent. All right, so the hypotenuse is going to be side AC. The opposite is going to be side, I'm sorry, did I just mess that up? No, I sure did. The hypotenuse is going to be side AB. I actually wrote that down, didn't I? The opposite is side AC, and the adjacent is going to be side BC. Problem number 2, give the sine, cosine, and tangent of E. Pause your video and try it now. Remember that the sine of a function, the sine of angle E is going to be the opposite over the hypotenuse. Hypotenuse is opposite the right angle. The opposite of E is here. And so my sine is going to be 4/7. The cosine of angle E is going to be the adjacent over the hypotenuse. Caught another hippie. The adjacent over the hypotenuse is going to be the square root of 33 over 7. And finally, the tangent of angle E is going to be the opposite over the adjacent, which in this case is going to be 4 over the square root of 33, which would simplify to 4 times the square root of 33 over 33. Probably not the prettiest number, but it is the answer. The tangent of E is 4 root 33 over 33. And finally, problem number 3, give the sine, cosine, and tangent of a 45-45-90 triangle. A 45-45-90 triangle is an isosceles right triangle. So I guess I should have said, let's try that again, of a 45-degree angle. Now I've got a 45-45-90 degree triangle. Let's say this side is x. Pause your video and see if you can give me the sine, cosine, and tangent. Okay, in a 45-45-90 degree triangle, if one side is x, the other side must also be x, and the hypotenuse must be x times the square root of 2. Let's assume that this is the angle we're looking at here, the 45-degree angle. If that's the case, this is the opposite. This is the hypotenuse. This is the adjacent. The sine of 45 degrees is going to be equal to the opposite over the hypotenuse, which is x over x root 2. X's cancel out. I get 1 over the square root of 2. Multiplying the numerator and the denominator by the square root of 2, I get the sine of 45 degrees is the square root of 2 over 2. What is the cosine of 45 degrees? Well, it's going to be the adjacent over the hypotenuse, which is x over x root 2. How about that? In a 45-degree angle, the sine and the cosine are the exact same number, the square root of 2 over 2. And finally, what is the tangent of a 45 degrees? The tangent of a 45-degree angle is the opposite over the adjacent, which is x over x, which is 1. If you can follow these simple steps that we've done here, as we continue to progress, things should be very easy. Please take time to memorize which angles are the opposite, adjacent, and hypotenuse, and which trig functions are the sine, the cosine, and the tangent. We'll work on this some more during our next video lesson.